Hello. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. But why? Why would matter continue uniform motion? Why the heavier is the body the harder it is to accelerate it? And the harder it is to stop it? Physics cannot give you any deeper insights. You should just accept that. At the same time, the assumption that I've made earlier explains all of that naturally. At least for elementary particles. In one of my previous videos I've assumed that each elementary particle is actually a discrete machine that consists of discrete pieces. E equals reduced Planck's constant multiplied by W. W according to that assumption is not an angular frequency, but the amount of discrete pieces in particle. Reduced Planck's constant according to that assumption is not quantum of action, but quantum of energy instead. Quantum of energy that causes quantum of action. Each discrete piece of particle stores one of 6 possible directions in space: left, right, up, down, forward, back. And moves all the particle in corresponding direction of space with constant momentary speed in infinite loop. Link to that video is in the upper right corner now. Please watch it if you want to understand the assumption better. Let's call the total amount of discrete pieces in the particle its total mass. Let's assume that we have a particle that consists of one discrete piece with direction up and one discrete piece with direction right. Its total mass is 2. It will keep on moving through space with constant speed until external force is applied to it and its state is changed. Let's assume that as a result of interaction particle gets one additional discrete piece with direction up. Its absolute movement direction changes. Now let's assume that we have another particle that consists of 2 discrete pieces with direction up and 2 discrete pieces with direction right. Its total mass is 4. 2 times higher than the total mass of the first particle. After the same amount of interaction is applied to this particle, its absolute movement direction changes less than the absolute movement direction of the first particle. We can add third particle with 3 discrete pieces with direction up and 3 discrete pieces with direction right. Its total mass is 6. Its absolute movement direction will change even less. And so on. The greater the total mass of the particle, the more discrete pieces it consists of and the more matter is needed to change its absolute movement direction. And this is how the inertia appears within the proposed model of elementary particle. It works the same way for particles at rest. Let's assume that we have a particle that consists of one discrete piece with direction left and one discrete piece with direction right. Its total mass is 2. It moves in cycles. After we add one discrete piece with direction up to it, it starts moving up. Let's assume that we have a particle that consists of 2 discrete pieces with direction left and 2 discrete pieces with direction right. Its total mass is 4. It moves in cycles. After we add one discrete piece with direction up, it starts moving up. But its speed appears to be lower than the speed of the first particle. In this case we say that the second particle has greater inertia. We can add third particle with 3 discrete pieces with direction left and 3 discrete pieces with direction right, and its inertia, resistance to acceleration, will be even higher. In the animation on the screen we can see how the particle's inertia grows as its total mass grows. The first particle on the left has initial total mass 2, the second particle has initial total mass 4, and so on. So, do you need the answer to the global why question? Should the possible answer I propose be taken seriously? Is it cool to know, what is inertia? Is it cool to know, why mass resists acceleration? Should the rest of the world know? Please note that the proposed assumption about the structure of the elementary particle explains some other phenomena too. You can find those explanations in other videos available on this channel. Thank you for your attention.